So let's get started. I think let me see. And yeah, if you're a developer and you're joining here, like doing very good learning this space um, of infrastructure and backends and Kubernetes. So the chapter is has a few sections. Is multi-cloud app infrastructure. He has a section first of like the challenges of managing infrastructure in Kubernetes. We'll get dig into like what type of infrastructure you're referring to. Mauricio wrote this. Second part is I think this would be two big parts, and the second one is around Crossplane, and he does actually a very good job with a few pages trying to explain Crossplane without including all the documentation around it, like very high level. So for more in depth, like the documentation and examples out there are useful, but it's hard to explain it in a short amount of pages. And then how does we're connecting the skeleton app to the infrastructure that we're deploying, and then looking back, he always add a section on every chapter of like every chapter, like how does this link to the overall theme of the book of like platform engineering. So the last one, chapter 4, was around GitOps and Argo CD, and then how that links back. So you always, I like that part. At least first book I've seen. I don't read that many books, but first book I've seen that it has a summary at the end of like how this links back to the overall theme of the book, actually explaining it. I think it's very good. I don't know if I gave him that feedback last time. I don't know what people think, but so far it's very useful. I'll let so my people for comment if you want to comment in chat or in the microphone. Um,
I really like that part as well, that he keeps taking you back to the actual focus, like how it actually relates to the platform engineering side.
yeah, because it's building blocks, right? Every component is a building block, and then it goes back of like how this building block goes back. Why does how this building block or this component fits into the platform engineering? And he kind of like links to that. So I think it's very good, that part. So let's get started. This chapter covers managing infrastructure for your cloud native applications. Some folks, instead of infrastructure, they call it like dependencies or backing. I think I saw someone in my org calling like backing services or backend services that your app rely on. Identifying the challenges on like managing those backend services, and to the scope of this book, what he's is referring is to running Kafka, Redis, and SQL database. Those three components. He has an email service, but I think he didn't mention it. But those three things, like a Redis, key value store, a database, and then a message broker. And those three things is not part of the app. They're like the app depends on it. The app needs to connect to them, but they're the people working on the app. Um, they're just like going to leverage those services. Um, and then he talks about the challenges, how to deal with infrastructure using Kubernetes constructs. I think we'll get into that about using Kubernetes API to provision those. Let's keep calling it. I think through the book, the calling infrastructure, keep calling it infrastructure. Um, so the first one is the challenges of managing infrastructure. So he mentions that like it usually involves third-party components, like I mentioned here. Like I don't know why it's showing the color thing. Um, databases, message broker, identity management solutions, and the key value store, which database, you can say Redis is the one. It's a database also. Um, but then mentioning like the modern cloud providers, that are great providing these managing services and allow your development team to focus on the building of the core features, um, and which brings value to the business. So I like that he mentioned this because I've seen folks, for better or worse, like trying to run these things inside a cluster app in production, and it depends on the like how mature, how big is the team, how knowledgeable they are. Trying to run things like Kafka or Redis or Postgres, uh, uh, inside the Kubernetes cluster with pods and PVCs, right? And they spend more time on that than actually the application, where some end users say like, let's not worry about that, let's just say managed service, database as a service, Kafka as a service, Redis as a service, and then the apps in the Kubernetes cluster will connect to the cloud provider, like for those services. And some people, like he mentioned in the book, you um, I think he mentioned like, that you can still provision those things, in the conference app as pods. Like there's pods and Helm charts that provision SQL. That's how we got it working, beginning, and those runs inside, and some people running dev and staging in there, and then for production they decide to run it, uh, as a managed cloud. It's in my experience, or they have like a pre-prod and prod running, cloud, and the other ones not, or just all of them running as managed services. And he mentions also the benefits is, pay as you go. Some of these services, the more you use them, you pay more. Less you use them, you pay less. They can scale. I think he mentioned somewhere, where was the part that, around scaling. I think at the beginning, on the chat, I think it was later. Even has a picture of
Yeah,
the
it's a bit
20.
later.
Yeah.
Yeah.
Um, yeah. Thoughts, ideas, comments, questions on like running this state. I think I call them stateful sets, right? Because I in Kubernetes stateful sets. Best practices. Do it, not do it. Any experiences that you want to share?
Well, I don't have an experience indeed about that, but I have a question.
Yeah, yeah.
So my question is, so the chapter is very nice, and the Crossplane uh, package or feature that you can add to Kubernetes is very nice indeed. I like it because you connect to cloud public, but something that I missed out in this chapter is the control cost of that infrastructure that you connect with the public cloud. And I'm wondering how you can manage that. It should be something outside of the cluster. It should be another team total different. That's the main question that I have in these early points about crossplay. How you manage the control cost, and when it started to trigger to charge you for use the MySQL or whatever.
Oh, like using cross, how to manage the cost, like the how much money you pay for the services.
Yeah, or at certain point, I would expect in this chapter that say that be careful that as long as you trigger the connection, it would be start to charge or something like that. There isn't
Oh,
any reference about the control cost of connecting your cluster Kubernetes with public cloud. And in other books, when other trainings, they always warn you about that. As long as you start to create something in AWS or Azure or whatever, they start to charge you. It's that the so I was wondering how to manage the control cost when you are using Crossplane.
yeah, yeah. So I can answer that, because I have experience in this area. So the first part is, um that crossplane is doing the same thing as if you go to the web browser on the console and create an SQL database, if you go log in into the browser and create a SQL database, for example, and you when you create that database, uh, and it depends on the service. So let's take database. So you create the SQL database, you go to the console and create it. You start paying for it, even if
Okay.
you don't use it. Like there's services that you just by creating an instance.
Mhm.
When you create some of them are serverless, some of them are not. So you have to be careful of like which one. But so for example, you create a Postgres database in the cloud provider, and you're like selecting an instance to say I want to like to have like 2 gigs of RAM and one CPU, for example. How this is how big I want the database. Basically, the cloud provider will spin up a VM and install the software, the SQL server for you, and then you start paying for it. It doesn't matter if you connect, the app connects to it or doesn't connect to it. You start paying for it. So in Crossplane, it's the same thing. So when you in Crossplane, when you create the Crossplane object, the Kubernetes controller will create the database, and you will start paying for it um,
Yeah.
without even using it. So yeah, we can tell Mauricio that maybe he can ask a warning here, right? That there's costs associated when you create these services, even if you don't use them, right?
Yeah, I think it would be nice. That's for me makes sense when he start to to give you the workaround or the way to play. They don't go for the public cloud. They go for connect to other Helm chart. So now makes
Yep.
sense for me the full chapter. So even he could kind of give that advice to say in order not to charge you that we are going to play with a Helm chart connection with Crossplane in order that avoiding extra cost.
And I think he did it. It's just a matter. I think I think there's a section in this chapter that he can add like a really
Yeah,
bold letter saying, "Oh, by the way, this example is using a cloud provider. You will get charged, right?" Depends. You will get charged if you use. It's always it depends. It depends. Some providers give you a free tier.
yeah,
So if you have an account, maybe a free tier is like 1 year, and just create an account. Maybe you can create a very small instance that you don't pay because you're under the free tier, right? For example, I work for AWS. We have a free tier, so sometimes you can create a micro or two micro VMs and run some software in there, Linux or SQL or something like that, and you don't pay for that first year. So watch out which one you're, or another cloud provider will give you like credits, or you can get
mhm,
some credits when you open the account, and then you have free tier. So if you're trying to learn this stuff and you create like an account on those cloud providers for the first time, like this month, usually they have a free tier, and you can get a way of creating small instances of Redis or SQL or a Linux server, or maybe a Linux server or a VM. You install the software. But in this chapter, and we'll get to it, Marisa did a good job, because at the beginning he did all the
yeah,
examples of Crossplane just with the Helm provider of Crossplane. So you are actually not creating, but at some point he shows creating a SQL database on the cloud provider, just because we want to teach, right? This is a book about teaching, not about like saving money, right? We
yeah,
can
yeah,
create
yeah.
another
It's
book about saving money, but this is about teaching, about learning, and
yeah,
people that have like, if you're working for a company and it's using this stuff, it doesn't matter. You're going to pay for it, and that's okay. That's part of the business. That makes sense. But
yeah,
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 some,
yeah. Sure.
Also, Mauricio had a list of cloud providers and how you will get free credits at the
yeah,
beginning of the book. He had a link. Obviously, this is just for learning purposes, not to rely on your business.
Yeah, yeah.
So
You
yeah,
can
yeah. He
learn.
has a good page. Actually, that's a really good. I think GitHub. It's a README. It's a very long page of a bunch of uh, telling you like where to go and get a free tier, and those type of things. But
Maybe I
uh,
missed out the point. Is just having a kind of warning about that.
yep,
It
that's
would be
fine.
nice.
Good question, and also a good question on because there are services that are, I don't like to use, anyway. There's services that are like, air quotes, serverless, that you can create an instance, and if you don't use it, you don't connect from the app. You don't pay for it. And I can mention one, like for example, in AWS we have Lambda. You can create a Lambda API or function, with a URL, and then you have a Kubernetes app or pod that talks to it. And if your app is not invoking the function, you don't pay anything. And then when you invoke it like 5 or 6 times, you pay something, or you go over the free tier, then you start paying, but you then it's free. So it depends. Um,
I have a question, but be aware that you're only on the first chapter. Mine might take long, and I actually could have asked it last week, but I forgot. I would be really happy if Mauricio touched the topic of the chicken and egg problem. So, if you really want your infrastructure defined as code, if you really want to use GitOps principles, you have to start somewhere. So, imagine you want to run everything in your GitLab pipelines, but you need to be able to host it somewhere. Where do you put that GitLab runner? And how does it all start? So I really want I don't know if in the upcoming chapters you'll be touching this, but there's a chicken and an egg problem. To be able to host your GitLab runners, you need to have some sort of code somewhere to be able to initialize everything. So then you will actually do GitOps, right? From that point on. So that was my question. Maybe if you want to touch that topic.
I don't know he touches that, but that's a space that I work on, and I have different projects for that. One is I can point, if you look for the GitOps bridge. This is based on Argo.
Yeah.
Um, it's the one that I use for the presentations that I'm giving. Um, is using uh, in this case infrastructure as code to create a management cluster, and then from that management cluster start creating the other resources. So
Yeah.
it's kind of chicken and the egg also, like you will use Terraform to create that. So this is a pattern, or Pulumi or SDK, or Crossplane, for example. So if you want to use Kubernetes YAMLs to define the management cluster, like going to run the GitLab runners and everything, and then from that you're going to create the other clusters. For example, we're talking about cluster creation. Um, you can create that first cluster using something like Kind. And one pattern is you use a Kind cluster, install Crossplane into it, or we have a project called ACK, or Capi, for example. Capi does this. You bootstrap a Kind cluster and then pivot, create that second cluster, the management cluster, and then move the the state of from the Kind cluster to the management cluster, and then delete the Kind cluster. The trick is, for that management cluster, you will need to have backup and restore,
Yeah.
kind of like
How would you?
Velero.
Yeah.
Um,
Mm-hmm.
like normal backup and restore of, like, I usually recommend Velero. Is an open source solution where you back up the whole etcd and maybe PVs. So if you destroy that management cluster, then you can restore it from there. You don't have to restore it from Kind, if that makes sense. So
Mm-hmm.
that's
Yeah.
one of the many solutions around that. I can, if you want to do a session, I can show you different patterns in that. Happy to do that. But that's the for the pure way of doing it. And but not everyone is there yet. So a lot of people want to use their current infrastructure as code, like Terraform or CDK or Pulumi, to just bootstrap something, and then that's what they use. So in practice, I don't see that much of a problem on chicken and egg, because no one is a purist. They're halfway there, trying to get
Yeah,
there.
that's true.
So they would just use, like, we use
Uh,
Terraform. We
I have
want to learn
similar, yeah, I
Crossplane.
have similar stories. Yeah,
Yep.
that they usually there is a Terraform enterprise somewhere anyway to provision the first ever thing. Then the rest is just sitting
Yep.
on GitOps. Yeah.
Yep. Yep. Let's go back to here. But yeah, good question. I don't mind. I don't know if people find this useful or not. You can mention something in Slack or say something. Um, So let's move on. So the app, if you've been attending here, is a conference web app that has different microservices, and in this case, he's mentioning that it depends on Postgres, Redis, and Kafka, and these are deployed with Helm charts, as you see in the Git repo that he has. I think I had it open somewhere. Let me see. Anyway, it's in the repo, and that's how you install it at the beginning. When you deploy the app in Helm, he has them as dependencies in that Helm chart. So when you deploy one Helm chart of the skeleton app, it says, "Oh, and by the way, deploy Postgres, Redis, Kafka as Helm charts." Um, so that's why he is saying here of doing a Helm chart installation when you do the Helm chart uh, install. So it's explaining like that portion of it. If you have worked with Helm, uh, it's simple to get. If not, Helm is a packaging system that you do a Helm install, and then it deploys the Kubernetes YAML files into the cluster, and do that. And then he mentions that the other way also to deploy these services, Postgres, Kafka, into them is using an operator. Um, I think that section is provide services. I think he mentioned it. He mentioned it here. So the other way is using a, where is it? I think I even highlighted it, the sections. Oh, here it is. Okay, we'll get into it. So that's deploying the Helm charts, and then how do you connect to Postgres? Is basically creating a the pod will need a secret, and then it will connect to Postgres, and then it's connecting to another pod that is sitting in the same cluster. So it shows here how that secret will look like for Postgres and Kafka. I think this has both. I think this is he got more stuff into it, but Postgres host and URL, it will be in a secret, and then it's mounted on the pod, and then you'll be able to connect to it. So this is how you connect to your Kafka, Redis. Here's Redis, and then this one is Postgres, and then Redis, and this is the information that you need to connect to it. So if you were and then later, if you were going to connect to Kafka, Redis lives somewhere else outside the cluster, maybe in another cluster. That's what I've seen also some users also doing is they set up two Kubernetes clusters, one for the stateless web app here, like the conference app, and another cluster for the stateful apps, and put the databases in there. And the reason they do it is because then to do cluster upgrades, you don't have to have that dependency. Like the one for the stateful sets can be, the upgrades can be longer term, and then the other one, since it's stateless, it's easy to just maybe do blue green or delete and recreate, or you can upgrade faster because you don't. There's no data to worry about that when you do upgrades. Then he mentions like the problem that you're going to have, you could have, right, if you run these Postgres. It shows the Postgres. If you have the app that is going to scale out, have many pods, services trying to connect to the Postgres SQL. When you deploy with a Helm chart, you deploy with a static number of configurations, so a static number of pods with a certain amount of memory and CPU, and it may not be enough to satisfy the amount of traffic that is coming in. And that's where he points out, this was the section I was looking for, is then what some folks do is, instead of installing the Helm chart, which is just installing a instance and be static, you can install an operator. He mentions here one Zalando Postgres operator, and then the operator is a controller that is inside the cluster managing the installation of Postgres, and I can do things that are mentioned in this bullet, like handle the rolling up updates of Postgres, cluster changes, volume resize without restarting the pod, database connection pooling with PG Boundary. I'm not very familiar with this operator. And then the saying supporting fast in place major version upgrades. And some folks use operators of Redis or Postgres and things like that, and they go into production in using those, and it's fine if you can handle it, and then you want to do it from Kubernetes instead of using a managed service, then you can do it like this with an operator for each one, and
It's
the operator will
yeah,
be managing the stateful set.
this Zalando operator is something I've seen a lot of times, and I just wanted to share this. Did you know that Zalando is a fashion retailer in Europe that is very
Oh no.
famous? Yeah, they have their own repositories and operators and stuff. So
Yeah, another
just
one
a
I
quick
was more familiar because there's a person that works for me in AWS. He used to work for that company. Is Crunchy database or Crunchy SQL or Crunchy Postgres. They also have I have a stats and they have an operator. Let me see if it's Crunchy
let's
SQL
see.
operator. Hopefully I don't get a food thing. Oh, Crunchy data. Here's another one that is popular. I will add that to the notes. Where's the notes for today? Um, that's one that I've seen some folks use. It's the Postgres. I don't know if it's still maintained or anything, but in the past, have people's. And there's another one. I think somebody from Commodore was pointing me to some cloud native Postgres or something. But anyway, either way, um, let me see what else. And then it gets into Crossplane section where Crossplane is an abstraction. It's basically a collection of controllers that implement an API. So in our case, implement a database API, Redis API, and by the fact that it's deploying into a cloud provider. So in here it shows like two cloud providers. So Crossplane is a framework. It's from the CNCF, and then the providers is like a plugin or something that you install on it. So there's a provider for Helm, which is the one that he's going to show in the book. There's a provider for Kubernetes, and there's a registry of a lot of providers. I think this is the link to the providers. And there's a marketplace from Outbound. Outbound is the company behind one of the companies behind about the CNCF project Crossplane, and they have a marketplace where it's a registry that you can find even for SQL or I think there's one for ServiceNow. I'm trying to remember. There's one for GitHub. There's one for Argo. So it's basically to create YAML files and then uh, basically deploy something, provision something. So in this example, this is creating a bucket, object storage bucket. And this is how a Kubernetes YAML will look like. We always have a spec section, your metadata, and then you put the information here. In Crossplane, you have like this is a managed resource. So you have like four provider, and then you put here the provider config. The provider config reference is like the provider configuration of like it handles like the credentials, basically like which credentials do you want to use, which is another resource to connect to it. And then if you don't put anything, it will be default, so he used default here, but you can create your own ones if you have like you can have one provider config for like one region or one account and another one for another with different credentials. You can do that also in Crossplane. And then this is a section that I said that he did a good job explaining kind of the Crossplane resources. The first one is he's talking about claims and compositions, which basically is I think he has it at the bottom. It's a group of resources that you put together as an abstraction I think it's the second one. This section here. So here's showing a PostgreSQL network and bucket. So it's kind of like a set or a collection that you want to deploy these things together and call it like Postgres SQL. So it will be like 3 APIs that you call, and then you create a composition, and then the abstraction is called a composite. And you can create a composite that is like, what is the name of the, you can put it in there like what is the name of the database that you want, or what is the size. um, and that the in Crossplane, that composite is a cluster global resource. So but if you want to create kind of a platform engineering aspect or have teams in different namespaces, then you would use something in here that you can see at the bottom of this picture called claim. I don't know if make it a little bit bigger or close this, make it bigger. A claim. So the claim is basically a namespace YAML file that is asking for like the database, and then it will use the composition to create the group of resources. I'm thinking he has a YAML here somewhere that it shows that. In this case, it's showing like using one cloud provider through Crossplane. In here is explaining some of the. I can talk about the AWS. I'm not familiar with the GCP, but in AWS you will need to have like um, the AWS credentials, key and access. But as best practice, it's better to use an AI role, and then that role needs to have access to like create the database or create a bucket. Uh, if you the only thing that you're going to create bucket and SQL, then only give it that those permissions. So you will need to have a role in Crossplane to connect. In here, he's explaining what are the requirements for the other provider. Let me see what was the next behavior. Crossplane behaviors. I highlighted a few things here. So the what is mentioned here is the idea is like once you are creating a database and creating a bucket, object storage bucket, they become Kubernetes resources. So any tool that you use to manage Kubernetes resources, or in this case, some people call it just YAML, you can use any tool that works with Kubernetes. You will use now. You can leverage it to also manage your cloud resources. So, for example, if you want to deploy with Argo CD, then you can use Argo CD because it's just deploying the YAML files in there. If you have something like policy management, like Kyverno or OPA or Gatekeeper saying like that act on Kubernetes resources, you can also apply them to Kubernetes resources that represent something in the cloud. So, for example, you can say, I want a policy that says no database created from this namespace should be larger than 2 gigs of memory. And then you can, Kyverno OPA Gatekeeper would not allow you to apply that YAML file. That way you can put some guardrails and standards, and that's kind of like go back to platform engineering. And then continued reconciliation. If you change something, you can configure Crossplane, and this also applies to ACK. If you change something in the YAML file and apply it, then it will try to reconcile and then create you the new thing in there. Immutable, it means that if you go to the console and try to be smart or change something that you should not be changing to the console, then you can have Crossplane like notify you that you have drift. I think that's what it mentions here. That the desired state in the YAML file the spec doesn't match the reality. So if you go to the console and change something on that cloud resource, then Crossplane will sync and tell you that something is different. And at that point, you can configure Crossplane to revert, right, or just notify you in read only. It talks about deletions. So this one is very tricky, I would say. I would add another caveat here. Some folks, when they deploy Crossplane resources and they do it in production, sometimes they deploy all the objects in Crossplane. Crossplane has a feature that you can say, when I delete this YAML file from my Kubernetes cluster, go ahead and delete the database. And sometimes you don't want that behavior because, I don't know, somebody make a mistake and delete the YAML file from Git or from Argo or from the resource. So you can leave it orphan, saying like, if I delete the YAML file, don't delete the real database in the cloud provider and just leave it orphan. And that is a safety gates. So if you really want to delete it, maybe you do an extra step of like putting it into a mode that says full control and then delete it, or you have another mechanism to delete. So that's something that folks have told me, that they sometimes are afraid of these automations, that it will do the wrong thing or disaster type of thing. So um, that's something that sometimes I recommend, like use the knobs that Crossplane gives you to not delete in certain environments, like in prod, maybe not, maybe in staging and dev, you can do it. And the other one is importing existing resources. Common question is, if last week you deploy a bunch of databases and VPCs and VMs using, for example, Terraform, and you want to migrate to Crossplane, how do you import existing things? And in Crossplane, you can put an annotation that you can see here to import, import, and then that object now is controlled by Crossplane or just read only. Any questions so far? I think I went too far. Let me see if there's any questions on the chat. Sabi, there's any questions in the chat?
If I could unmute myself. We don't have questions, but a comment from Safeddin. He's saying, I'm not a big fan of DB on Kubernetes. So the conversation went on from that point.
Yep. Yeah, Tony's saying like, if you just, if you're going to go that way, use an operator. Let me see. Yeah, this section is around Crossplane, how to use it. This is the example. I think it was mentioned by. This is the section that I mentioned at the beginning. Was this is how, if you deploy the Helm chart of the conference app, you can see in the dependencies it will deploy also Redis, Postgres, and Kafka as a Helm chart. And then this example, what is saying is install infrastructure equals true, then it will deploy those Helm charts. Like, I think he put a condition somewhere. Where is it? Oh, here, line 3. As you can see here, it says condition install dot infrastructure. So in your values.yaml, if you set that to false, then it will not deploy these Helm charts, because in this example, in this chapter, what he wants is to deploy Redis and SQL with Crossplane. Crossplane will use the Helm provider to install them with Helm, but at least give you the abstraction that you can now use those claims for something else. And that's why he goes into here of like explaining how that he picks one, like he picks the database on how to create the composition that basically has in here the Crossplane. This is the composite, the API, and then this is the composition saying like, I want to use the Helm provider called Kind Release to deploy the Bitnami charts, and then this one should say Redis, right? It's deploying Redis as a Helm chart. So this is why it's useful to have the Crossplane Helm provider, because when you're doing dev or locally in kind, you can deploy the same abstraction with Helm. So this is what explains in this section of the book. At some point there's a claim. Where's the claim? I think is this one. Yeah, so this is the claim. This is the YAML file that says, give me a database. And you can set it to a namespace. He didn't put a namespace here, but looks like he's deploying in default. And then the composition selector, he's using some conventions on the labels on the composition, say local. So he doesn't want to use the cloud. Um, and then he passed the size, but I think the size is ignored if you're just going to deploy the Helm chart. And then this is the composition for that database. See, there's no use of that mock data or anything. He just deploys the Helm chart. So yeah, like Francisco was saying, he goes and does the whole example in Crossplane without like using a cloud provider, so you don't have a risk of like getting charged or the cost, or also like you don't have to configure the authentication or get an account just to learn Crossplane. So I think it was a good idea that he used the Helm chart. And this one is also local, and he deploys that one, so Redis and the database. And I think this is the one, Francisco. You still there, Francisco?
Yeah, I'm here. I'm here. Yeah,
So I think this is where if you're going to use this one,
yeah.
right, then this one is going to use a cloud provider, and then if you are not in the free tier or such and such,
You need to
you
pay.
you might pay. So this might be the way, the point that this is feedback. You can highlight a section and give feedback here and put something in there, like it would be useful to like add a warning or something like that, right?
Yeah.
That you're going to get charged because you're going to create a database that consumes memory, right, and CPU.
However,
um,
Yeah.
all the example that you provide using help chart with Crossplane, for me is useful because if you have a kind of a lot of help charts on premise, I mean, developed by the own company,
mhm.
Crossplane works as a kind of interface for those help chart that you have on premise. If you have something on premise, that's what I love it of that part of the chapter.
Yeah.
That if you think maybe a company that they have their own implementation of MySQL in terms to provide inside of their own artifact, you use Crossplane as a kind of interface for Helmchat. I like it.
Well, the thing is, my recommendation is use it for Helm charts as long you're going to use it for something else. If you're not going to use it to create an abstraction, the usefulness of the Helm is to have an abstraction of like be able to switch from the real database, which could be somewhere else, or a Helm chart. Like for example, it could be a real database in premise versus the Helm chart, um, or the real database in the cloud provider and the Helm chart. If you're just going to use as the Helm chart, then you are buying a lot of technical depth of using Crossplane just to deploy Helm charts. So in that case, I would recommend just use Argo CD, and then Argo CD will just deploy just Helm charts wherever you need on every namespace, on each namespace with different release names, and then you don't have to buy that. You don't have then you don't have to use Crossplane, because then you'll be using Crossplane the wrong way. Like you're using Crossplane just for the Helm charts, then you're like holding it wrong, kind
Yeah,
of
yeah,
thing.
yeah. I got the point. Good point. Yeah.
Yeah, just because you can make Crossplane deploy Helm charts. It's some I found it useful in small use cases. This one was one like be able to switch. Another one is to what Sebi was asking for chicken and the egg, where I would use Crossplane to create an EKS cluster, and then I want um, uh, sometimes I want to deploy something with Helm on it, uh, 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 on directly on it, like something to bootstrap, like Cilium, for example, or something like that, to deploy it. Or I can just, if it's a spoke cluster, I will say when I add the new cluster, Argo CD will deploy everything on it. So it depends what you're, if you need something like to bootstrap or not. Sometimes you don't. So it depends.
Yeah,
But yeah,
but I like it what you said because maybe I was over engineering
yeah, you
the use case.
yeah, you would use Crossplane, but the benefit is using it for external things, right? If you are like, it could be any API, right? But most of the people use it for cloud. Um, and then this is the section where these are like objects, right? Get MBS will give you like Kafka, right? And it will tell you that it's true and it's sync. So the Kafka provider, this sync and ready is a little bit sometimes confusing. The sync means that the all the YAML files are in sync, but and the ready is maybe the Kafka takes 5 minutes to be created in the cloud provider. So until like that Kafka is like ready for usage, that ready will not be true. So that will be a trigger for your app or for whatever composition to move to the next stage. So here's all of them: Redis, SQL, and Kafka running. Um, and at this level, you don't know if you're running on one cloud provider or the other cloud provider, or is it running locally. It's an abstraction. Uh, in this case, he's the secrets are here. So the when those cloud resources are created, the pod needs the secret to be able to connect to Redis, to be able to connect to Postgres, to connect to those things. Sometimes you will use a secret in some cloud providers. I'm speaking because of the one that I know, which is AWS. I work there. Sometimes you don't need a secret. You can use something like a pod identity or IRSA that will make the pod just assume a cloud role or a work identity that has access to the database. So you don't need actually the username and password or of to connect to things. But most people use secrets. Um, I think this is it. This is the you see here the line number one. Sorry, line number two says infrastructure false. So when you deploy now, the Helm chart is saying like, I don't want you to deploy through Helm charts. I want you to deploy through Crossplane. And then he's putting here the URL, which I don't think is needed. It's one way of doing it. You can have like the secret have this information on how to connect. Because in Crossplane, maybe it doesn't have this implementation. In Crossplane, you are able to augment the secret with more information, and you can put the URL in there. So you don't need this. The secret name you might need that secret to be created to connect to it. I think this is just specific to the Helm chart. Maybe it's not just in the cloud provider. Um, and then this is how everything comes together. And I think that's it. I think this is the section that was mentioned at the beginning, which I already said, of like how this links back to platform engineering on using Kubernetes APIs or Kubernetes resources or Kubernetes YAML files to define dependencies, backend dependencies, and in this case, to the extent of like people are using Crossplane to deploy Kubernetes clusters, like Inception, right? From a Kubernetes cluster, create another Kubernetes cluster, not just like databases or buckets. So you can have a multi-cluster fleet management way of doing that through Kubernetes APIs. That's a space I work on. So you can reach out for more information around that. Um, and then this is how the platform engineering works, right? By creating a YAML file and put it in Git. I think he mentions that like then Argo CD will pick it up, deploy to the cluster, and then that will deploy a cluster, will deploy a database. Um, and then I don't know if he includes Stage in this book or not, but I use Backstage as a portal or a website that people will go in, log in, and then say, I want a database, or I want an app with the database, or I want a Kubernetes cluster. Put a few fields in a form, and then click go, and then that will create the YAML file that is sitting in Git that Argo CD will deploy, and that's a project that I work on, that pattern with the Canoe project, CNOE project. If you want to learn more about that, that's a project, open source project that I'm working on. Let me see where it is. Canoe.io. It's a reference implementation on creating internal developer platforms, and that's the pattern. The pattern that I described, literally the pattern that we have is like using Backstage to deploy um, resources. Actually, I'm doing a live stream next week on this. Using Backstage and Canoe. Let me go back to the book. I think that's it. Yeah, he talks about the GitOps, right? GitOps sync. We'll configure the YAML files and then provision the cloud providers. Because I read it this morning, so I remember that's why I was talking about it. Yeah, he mentions the GitOps is the way. I call it like GitOps infrastructure. Like now you can do GitOps for infrastructure instead of doing imperative CI/CD pipelines like other tools. Like you have to run and apply every time you want to change something. In this case, Kubernetes has a controller always running, reconciling your cloud resources. I think we're a little bit over time. Any questions, comments? Let me see. Some people drop. I think because at top of the hour, people have other stuff. But this is recorded. The last section, I'll post it on YouTube. Any questions on chapter 5? I think it was mostly awareness of like that you can use Kubernetes APIs to as an abstraction to cloud resources. And one of the projects is Crossplane. And he has an example. Okay, so people saying that section was good. So yeah, next week will be chapter 6, right?
We have requests for Canoe. No.
There's no book for Canoe. Maybe I should write a book and then have a session. We only do books here. But yeah, watch. Look at my LinkedIn. I'll post it today. Next April 9, I'll be doing with platformers. Guy from Commodore. We're doing a session on Canoe of like how to bring up an IDP in 5 minutes. I think 5 minutes. I'll show if we demos there. That should be the session. And then the next chapter is chapter 6.
And we'll have, as far as I remember, Mike running next chapter.
Yeah,
Micah,
Marisa, I think. Marisa will be here for both. Can drive that. Yeah, I haven't read this, but yeah, I'll be ready. I'll be ready for next week on chapter 6, and we almost passed half of the book. So it should be good. Thank you, folks, for joining today. I know it's Friday, and so appreciate the attendance and the participation. So
yeah, thank you.
Have
everyone,
a good weekend.
And see you next week. Have a happy
See you next
weekend.
week. Have a good weekend. Bye.
Cheers, everyone. Bye-bye.